So hello everyone, welcome back to my channel. My name is Santo Digital Vasta. So for this day we will do the activity in NetAccount which is in chapter 3. The title of this activity is Packet Tracer Investigating the TCP, IP and OSI models in action. So the objective of this activity is the part 1 examine HTTP web traffic while the part 2 is display elements of the TCP IP protocol suite. So here is the background of this activity. So this activity is intended to provide a foundation for understanding the TCP IP protocol suite and the relationship to the OSI model. Simulation mode allows you to view the data contents being sent across the network at each layer. So as data moves through the network, it is broken down into smaller pieces and identified so that the pieces can be put back together when they arrive at the destination. So each piece is assigned a specific name, protocol data units PD or the PDU, and associated with a specific layer of the TCP, IP, and OSI model. So Packet Tracer simulation mode enable you to view each of the layer at the associated PDU. The following step leads the user through the process of requesting a web page from a web server by using the web browser application available on a client PC. So even though much of the information display will be discussed in more detail later, this is an opportunity to explore the functionality of Packet Tracer and be able to visualize the encapsulation process. So sorry for the background crying of the baby because there's a baby here. Okay, we go to part 1. So, examine HTTP web traffic. So, in part 1 of this activity, you will use Packet Tracer simulation mode to generate web traffic and examine HTTP. So, step 1, switch from real-time to simulation mode. In the lower right corner of the Packet Tracer, interface are tabbed to toggle between real-time and simulation mode. So PT or the Packet Tracer always start in real-time mode, in which networking protocol operate with realistic timing. However, a powerful feature of Packet Tracer allows the user to stop time by switching to simulation mode. In simulation mode, packets are displayed as animated envelopes. Time is event-driven and the user can step through networking events. So letter A. Click the simulation mode icon to switch from real-time mode to simulation mode. So we need to click the simulation mode here. Okay, like this. Then select the HTTP from the event list filter. So we need to event list filter. Okay, find the HTTP here. So this. Okay, so HTTP may already be the only visible event. Click Edit Filter to display the available visible event. Toggle the Show All Non-Click box and notice how the checkbox switch from unchecked to checked or checked to unchecked, depending on the current state. So click this Show All Non-Checkbox until all boxes are cleared and then select HTTP. Click anywhere outside of the Edit Filter box to hide it. The visible event show now the only display HTTP. Okay, just only click. Oh my god. Okay, so it is done. Next activity. So we go to step 2. So generate web HTTP traffic. Currently the simulation panel is empty. There are 6 columns listed across the top of the event list within the simulation panel. As traffic is generated and stepped through, events appear in the list. So the info column is used to inspect the content of a particular event. So note, the web server and web client are displayed in the left panel. So the panels can be adjusted in size by hovering next to the scroll bar and dragging left on the right when the double-headed arrow appears. So letter A. Click web client in the left panel. So just click the web client here. Then click the desktop tab and click the web browser icon to open. So we go to desktop. Okay. We go to web browser. So in the URL field, enter www.osi.local and click. Okay. www.osi. Oh my god, why it's big. www.osi.local and we need to click go. Okay, because time in simulation mode is event driven, you must use the capture forward button to display network event. So for doing that, we go to click this icon. So it is called capture and forward button. Okay. Okay, wait. Okay. So what happened? It is simulation. Okay. Just wait. I will edit it. What happened? www.osi.local here. Then go. Okay. Oh, like this. So we need to click for button. Okay. So click the first colored square box under the event list. No. Okay, we go to step 3, explore the context of the HTTP packet. So click the first colored squared box under the event list, info column. It may be necessary to expand the simulation panel or use the scroll bar directly below the event list. Okay, we need to click the colored box here, this. Okay. Okay, so what happened? Where's the... Okay, just wait. Okay, sorry. This is the God, dumiit pala. Okay. Sorry for the camera, because I use the camera of my phone because my OBS is not working anymore, and my laptop can what can what ba can basta ganun. I don't know either. So the PDU information and device web client window display. So this is it. So in this window there are only two tabs. So the OSI model and the outbound PDU details. So this is the OSI model and the outbound PDU details. Okay. So because this is the start of the transmission, as more events are examined, there will be three tabs display, adding a tab for inbound PDU details. When an event is the last event in the stream of traffic, only the OSI model and inbound PDU details tab are displayed. So B. Ensure that the OSI model tab is selected under the out layer column. Ensure that the layer 7 box is highlighted. Okay, highlighted. Wait. Okay, what's the next? What is the text displayed next to the layer 7? So out layer is highlighted, so it's highlighted. Next, so it's level 6 and level 5. So what information is listed in the number step directly below the in layer and out box layer? So in layer, so it composed of layer 7 to 1, then in out layer, so layer 7 6 5 4 3 2 1, also the TCP SRC port 1028 26 DSD port 80, and so on. So next, so click next layer. Layer 4 should be highlighted. What is the DS port value? So the DSD port value of layer 4 is 80. So click next layer 3. Layer 3 should be highlighted. What is the DEST IP value? So the destination IP will be 192.168.1.254. Then in next layer, what information is displayed at this layer? So the information that display is the layer 2, the internet 2, the header 0.06476CA4DEE, and 0001.9689.401D. Okay, so this is the okay. It's so very hirap. So we are go to do the only part 1 of this activity. So model tab. So click the next color box under the we are in letter F. Click the outbound PDU details tab. Information listed under the PDU details is reflected of the layer within the TCP IP model. So we go to outbound PDU details. So the information listed under the Internet 2 section provides even more details information that is listed under layer 2 on the OSI model tab. So the outbound PDU details provide more descriptive and detailed information. So the values under DEST MAC and SRC MAC within the Internet 2 section of the PDU details appear on the OSI model tab under the layer 2 but are not identified as such. So what is the common information listed under the IP section of PDU details are compared to the information listed under the OSI model tab, which layer it is associated. So it is in lay. Okay, this is the outbound PDU what we call it? Details. Okay. In IP. So in IP, there's an IHL, the DSCP, the TL, the prog offset, the TTL, the PRO, the CHKSUM, the SRC IP, which is the 192.168.1.1, then the DST IP, which is 192.168.1.254. Okay. So what is the common information listed under the TCP section of the PDU details as compared to the information listed under the OSI model tab, and with which layer it is associated? Okay, go to TCP here. So the information that is in TCP is the source port, which is the 1026, the destination port, the sequence number, the acknowledge number, the window, the urgent pointer, the checksum, the option, the data variable length, and the FADIN. Okay. So what is in the host listed under the HTTP? What layer would this information be associated with under the OSI model? So this is the HTTP here. Okay. The host is www.osi.local. So click the next colored square box under the event list info column. Only layer 1 is active, not grayed out. The device is moving the frame from the buffer and placing it on the network. So we go to click the colored box here. So only the layer 1 is highlighted here. The 2, 3, 4, 5, 6, 7 is not. Okay. So advance to the next HTTP info box with the event list and click the colored box. This window contains both in layers of out layers. Notice the direction of the arrow directly under the layer column. This pointer upward indicated the direction of information. Scroll through this layer making note of this item previously viewed. At the top of the column, the arrow point to the right. This is the note that the server is now sending the information back to the client. If you're comparing the information display in the layer column with that of the out layer column, what are the major differences? God, I don't know. So in layer in layer, so I think it's in. So this is the major differences of the two. Okay. So click in the outbound PDU details tab. Scroll down to the HTTP section. So we need to scroll down here. Okay. So what is the first line in the HTTP message that displays? So in HTTP data, access language ENUS accept. So connection is closed. The host is WWS OSI local. Click the last colored square box under the click the last colored square box under the info column. How many tabs are displayed with this event and why? Okay. So the event is 1, 2, 3, 4. So it composed of 4 events here. So Okay, so we are done in what we call that, in investigating the TCP and IP and OSI model in action, which is in chapter 3. So that's all for today, and see you in my next video. Bye bye.